Hello everybody, my name is Gustavo Jantsch and this lesson is for the week 1 of Introduction to Music Production at Coursera.org. I am from Porto Alegre, Brazil, and in this lesson I will teach you about the timbre and its components. The goal is to learn about the timbre and its characteristics to help us to understand how to use and shape the sound. So the first question is, what is timbre? In music, is known as the tone color or tone quality. Is the quality of a musical note or sound tone that distinguishes different voices and instruments. Is what makes a steel guitar sound different from a nylon guitar, for example. The timbre is made of harmonics and envelope. The envelope is the shape of the sound over time, the amplitude variation. In this picture is the part that I marked with blue. That's what we usually see in almost all of the DAWs that we use today. Envelope has 4 parameters. Attack, the time that the instrument or sound needs to go from the relative silence to the maximum of its dynamics, and it happens when we pluck the string of a guitar or when we hit the key in the keyboard. After that we have the decay, that is the time that the sound needs to leave its maximum volume and go to a more constant state of the sound, that is called the sustain of the note. That will vibrate constantly for a certain time and then start to become more and more weak till it stops. This is the release time. We used to think that each note is related to only one frequency, but in fact each note is made of a lot of other frequencies. 2 of them are very important to name. The fundamental frequency, that is the lowest frequency, and its pitch is used to name the note, like 440 Hz is related to the A note, and the dominant frequency, that is the frequency that is most heard, and it's always a multiple of the fundamental frequency. Some instruments like the transversal flute, the dominant frequency is twice the fundamental. The other frequencies will be called overtones, partials, or harmonics. Overtone is any frequency higher than the fundamental. The fundamental and the overtones together are called partials. Harmonics are partials whose frequencies are integer multiples of the fundamental, including the fundamental, which is 1 times itself. Here in this picture we have the harmonics represented as a vibrating string. The relation between the harmonics is the same as the notes in a scale. Here in this picture, representing the fundamental, we have an C. And then we have the first harmonic, and C an octave high. And then we have the second harmonic, a G, a perfect fifth. And then we have the third harmonic, a C on the second octave. And then we have the major third, the minor third, and so on. Now, for us to visualize all those frequencies, I will use a spectrogram. And this program, called Sonic Visualizer, that is totally free. You can download it from the sonicvisualizer.org website. To use it, you need to download this software and the analysis plugins. For our spectrogram, I will use this clip that is a violin playing several notes. Here we have the first representation as sound wave. For us to transform it in a spectrogram, I will use this option: Transform, Analysis by Category, Visualization, Adaptive Spectrogram. Don't need to change any parameter, just click on the OK button, and then the program will build the spectrogram. The spectrogram is made of, in the bottom you have the fundamental frequency, and above the fundamental all the partials that build the timbre of the violin. In the left we have the frequencies related to each partial. So here we can identify the frequencies that we want to boost or to filter. Let's listen and relate the sound that we are listening to the visualization of the frequency. So that's all, folks. Hope you have enjoyed and find it useful. Have a good production. See you later.